Hello, my name is Avetisyan, and today I will present a work named Cross-Lingual Plagiarism Detection. Two are better than one. Let's now briefly understand what is the cross-lingual plagiarism detection. So cross-lingual plagiarism detection refers to the act of copying some text from source, translating it, and then presenting it as one's original work without proper citation or attributes. So this work was done in collaboration of two organizations, ISPRAS and Anti-Plagiarism, and we'll examine two existing state-of-the-art approaches from Anti-Plagiarism and ISPRAS. These approaches share the same structure, so we try to utilize that in our work. So the structure is as the following. The first step is the pre-processing step. So we pre-process just the document that come to us. The second one is the language independent representation. So we have the documents in different languages. So we have to bring them into one space so we can some kind of search. Then the candidate retrieval step, the step where we are trying to minimize the base from which we are searching. So we want to get the top K candidates for the following step. So the detailed analysis step, the fourth one, is a step where we have these top K candidates, and we want to say that this sentence was plagiarized exactly from this sentence or this paragraph, or plagiarized exactly from this paragraph from this document. And the final step is the report generator, when we generate the final report and give it to the user. So let's briefly now see the ISPRAS algorithm. So the first step, the pre-processing step, we divide our source documents into the paragraphs and divide our suspicious documents into sentences, lematize both of them, delete the stop words, punctuation removal, and go on. So the language independent representation. In case of ISPRAS algorithm, we used universal word net to try to create a multilingual synonym cluster, so that in one cluster we could have home, casa, dom, and so on. So for the words that we didn't have in the universal word net, the translations of which we didn't have in the universal word net, we tried to supplement with machine translation, and finally we got the clusters. So afterwards, the candidate retrieval step, we use that clusters to replace our words in suspicious sentences in source paragraphs with the cluster indexes, and afterwards we search the text as the cluster indexes. So the search process was done using the inverted index and ranked by the BM25 ranking function. The detailed analysis step. So here we had finally for one sentence, we had top K fragments, candidate fragments. We divided that candidate fragments into sentences, and then sentence-wise compared the suspicious sentence with the original sentences, the source sentences. It was just a binary classification. We named it translation detection. So yeah, let's go to the anti-plagiarism algorithm. The pre-processing step here, the anti-plagiarism algorithm does machine translation of the suspicious documents, then a stemming, stop words removal, and punctuation removal. So here in the language independent representation step, we already have the text in the source language, so we don't have to use some kind of multilingual synonym clusters or something like that. So here they use just synonym dictionaries, different synonym dictionaries, and supplement them with fast text as the analog of our machine translation. So then they have the clusters and they use them. So afterwards, the candidate retrieval step is pretty similar to the ISPRAS algorithm, but here it works on the level of n-grams, word n-grams. The searching process is also processed with inverted indexing, and the ranking function here is min hash. The detailed analysis step. So here we have, after the candidate retrieval step, we have source documents, we have suspicious top case, we have suspicious document, top case source documents, and we somehow want to find the needed fragments, the plagiarized fragments. So we divide both sides into fragments. Use LabS here to have vector representations, and cosine similarity, and we get the plagiarized fragments. So yeah, the fifth step was the report generator. We used the one that anti-plagiat rule provided. So the report generator step just merges, deletes, or filters the plagiarized fragments, found plagiarized fragments according to their length or some other attributes. Yeah. So as I said, we are using two state-of-the-art algorithms. So we wanted to compare them between each other. So we created our own evaluation dataset. The evaluation dataset was based on Wikipedia. It utilizes four languages: Armenian, Russian, Spanish, and English. There are 25,000 source documents for each languages and 300 suspicious documents for each languages. And each suspicious document contains plagiarism from all of the documents from all other four languages. So in one suspicious document, you can have plagiarized fragments from 4 languages. How we created it? So for each suspicious document, we just took from 1 to 10 source documents. We randomly selected some fragments from them, then machine translated, and replaced 20 to 60% of suspicious document fragments with that translated documents. So yeah, the experiments. So we had these 2 algorithms. We tried to somehow merge them to get higher results. We tried 2 types of merging: combinational merging and sequential. So the first one, combination merge. Combination merge, as I said, we have the 2 similar structures of 2 algorithms. So we tried to replace one step of one algorithm with the same step of the other's algorithm. So we had these 8 passes. Let's name them passes. And the first one and the 8 ones, are the full anti-plagiat rule algorithm and ISPRAS algorithm. The other ones are the combinational merges. So we replaced one step with another step of one algorithm, and so on. So, but we had to somehow fine-tune, so to tune somehow these 2 algorithms so they can work with each other. For example, for anti-plagiat algorithm, we had after the candidate retrieval step, we had 2 documents to compare, but the ISPRAS algorithm detailed analysis took sentence to sentence, so we had to somehow get sentences and compare them pairwise. Yeah, actually, let's see the results of full anti-plagiat rule and ISPRAS algorithm. We can see that we have the Plex score, this Plex score. So the Plex score is some kind of weighted F1 weighted by the granularity score, and the granularity score represents the intuition is like this: you have a big fragment, and the granularity show in how many small fragments you found that big fragment, that big plagiarized fragment. So ideally, you want to find one big fragment as one big fragment. So ideally, you have the granularity score of 1. Yeah. So the combination merge approach actually didn't work. So because different parts of algorithms worked pretty bad with each other, and they are focused on different tests. So I won't focus on this. We got a pretty decent results in this 6th step, but they are also lower than the actual ones. So afterwards, we wanted to try something new. So we have here that we can see here that the precision score of anti-plagiat rule algorithm is high enough, and the recall score of ISPRAS algorithm is high enough. So we tried to use that in sequential merge. So as I said, we had a decent results on 6 paths, so we used that too. So we used the ISPRAS algorithm fully, and then connected it with the last part with the anti-plagiat detailed analysis step. So we tried to keep the same recall score and to increase the precision. So here you can see the results that we significantly surpassed the full anti-plagiat and ISPRAS algorithm by from 30 to 40, 50%. And so actually the sequential merge approach worked. As I said, one suspicious document could contain plagiarism from different languages. So here the results are averaged, and here are more detailed. So we have documents in these languages, suspicious document in these languages, and these are the languages from which were plagiarized the fragments. So we can see that here for Armenian we have the worst results, but still the results surpass the ones that we had from the actual for the actual algorithms for example the Spanish or English or Russian for the big languages. Yes, here we also present the mean lengths of found fragments, actually the character number, symbol number. So we can see that there is some dependency, or that the long fragments are found and the short fragments are difficult to find. Yeah, so we have a metric change depending on candidate numbers. So we had a candidate retrieval step where we have top K candidates, and we tried to calculate the accuracy of the algorithm according to the change of that top K number. So we can see that the number rises when we come up to top 50 candidates, but at the same time we have a linear dependency of time complexity. So when we use the top 50 candidates for one document, our document you can interpret as one Wikipedia article. So for one Wikipedia article, we spent like a minute to find the plagiarism. So as a conclusion, we created a novel cross-lingual plagiarism detection approach that significantly surpasses the state-of-the-art ones that it was based on. We created a new dataset for cross-lingual plagiarism detection, and we developed a method that is applicable for under-resourced languages. We showed that on the example of Armenian language. Thank you.
Thank you, Karen. Do we have any questions from the audience? Yeah.
So thank you. You combined two initial algorithm, and can you repeat what main difference between anti-plagiat algorithm and your algorithm? Why in the first case was high precision and the second algorithm high recall? In what place in this flow such difference contains?
Okay.
Because we see many similarities such as translation, BERT or LabC, and where from which place such difference?
Okay, actually, thank you for your question. Actually, the difference came from each part. So from each part, for example, the candidate retrieval step for anti-plagiat algorithm had more precision than we had, the ISPRAS algorithm had, and the detailed analysis itself too. So the both main parts, actually, the candidate retrieval part and the detailed analysis part, show the same.
So
Had the same.
maybe the initial aim was to be more precise, and maybe they
Actually, it could be because of the thresholds we used. We both used. So, but for the ISPRAS algorithm, I can say that we used some kind of furious threshold. So we wanted to be precision high, but couldn't achieve that. So yeah.
Thank you. Other questions? It seems to be not yet. I have a question of myself. Maybe I have missed this, but as far as I understand, you have prepared a data set to train your algorithm on. As far as I understand, it is a synthetic one. Is it true?
No, we didn't train our algorithm on this data set, but the data set was synthetic one. Yeah, we generated it.
So you evaluate your algorithm on these data sets.
Yeah.
Okay. Have you? I think the question is kind of obvious. The synthetic algorithm has obvious flaw, like it's synthetic. It's not like human written or something. Have you tried to maybe compose a small human written algorithm to just compare some distributions or something?
So yeah, thank you for the question. We are now actually we are working on the real data from real masters, PhDs, or this kind of documents. So we'll have that results.
Oh, that's great.
So this was the initial experiments. Yeah.
I see. Have you the plans to, I don't know, maybe share the results, or it's since it's students, maybe it's some private information or something?
You mean that set, the new data set?
The new one, yeah.
I can't answer to that question yet, I guess.
Yeah, I see. Of course, it's not that easy. At least could we think of it like we can ask you to share the data set, not like share it publicly, but ask by, for example, myself. Would I ask you to share the data set with me?
Yeah, of course. We have to decide it with the anti-plagiat root team, so I can't say for us both, but yeah, I guess it won't be a big problem.
Okay, I see. I'm asking because I'm personally myself really interested in lower source languages, and I think the Armenian is one of the interesting ones of the lower source. So we need more resources for any language, but especially for Armenian too. Yeah. Do we have additional questions? Maybe. Yeah.
No. Okay. Yeah, so my question is this. So if you take a sentence and try to translate from Armenian to English and translate it back, so it is like one of the baseline methods of doing paraphrasing, right? And I've seen people doing that in order to, avoid to be detected as a plagiar. Because some cases, as far as I know, plagiarism is defined as like copying some segments without changing the wording, right? So what happens in this case? Like it is like a little bit difficult for me to understand what the plagiarism is in cross-lingual space, because like you are not preserving the word ordering, because like different languages have different word orders.
So yeah, actually this part, the detailed analysis part, was exactly trained like that, cross-translating to back and forth. So we can find that kind of sentences, but we don't say, we find and we show it to the university. We don't say it's plagiarized and or not. We just show it to the university. University decides what to do.
Yeah, so you care only about high recall, and yeah, then you want to filter them out.
Actually, no, we care about precision too, but you can see that the results are not good for the precision. So yeah, we mainly focused on the recall.
Yeah, and one more thing, what will happen if I take very frequent sentence that happens like to be in many works and try to compare, like calculate the plagiarism score with its translation in other language? Will it yield very high score of a very high probability to be plagiated or not?
Yes, it will, but if it is a lone sentence and not a fragment or paragraph, it will be deleted on the step of report generator. So it will be some kind of filtered. But yes, it will be, if it is a very popular fragment, it will be found.
Okay, thank you.